Hello and welcome to the presentation of our paper. Do communities and developer interaction networks align with subsystem developer teams? An empirical study of open source systems. I'm Usman Ashraf and my co-authors are Christoph Mardon, Atif Mashpour and Alexander Ikiat from Johannes Kepler University, Austria, and Sebastiano Penicella from Zurich University of Applied Sciences, Switzerland. Open source software development is considered as a successful example of large-scale global software development. In this environment, software systems do not have a pre-assigned organizational structure, so developer can contribute to any part of the system. These developers tend to self-organize in emerging communities, which also have a significant impact on software quality. There are many researchers who have built automated tools analyzing developers' interaction data from various sources such as version control system, mailing list, or issue trackers to investigate how these communities are formed in open source projects. However, we do not have conclusive studies regarding whether these emerging communities align with the developers team working on different subsystems. So our study in this regard provides useful insights. So the figure elaborates the concept further. The developer interaction network on the top shows edges between developers based on being involved in the same issue through activities such as reviewing or commenting. So a community detection algorithm assigns developer to communities shown here within blue borders based on the developer interaction intensity as indicated by line thickness as well. So developers who interact often tend to form communities. Move further, the lower part of the figure depicts file and issues belonging to three subsystems A, B, and C. Subsystem team members are then those developers that change an artifact belonging to that particular subsystem. Note that the subsystem member set may overlap, as in open source products, key developers are often involved in multiple subsystems. So in our example, developer Dave is a member of all three subsystems. However, Carol is a member of subsystem A. In this example, when comparing the members of subsystem B, which are Dave and John, we notice that they are actually member of different communities. However, they belong to the same subsystem, and there is no edge between them. So this could be a warning signal about poor communication or coordination between the two. Investigated in 10 open source projects, the extent to which emerging open source developer communities are aligned with the subsystem structure. This perspective is useful for practitioners and researchers that could use such information to identify subsystems where developers coordinate insufficiently. I briefly go through each step of our approach here. We select project from Jira and GitHub, and in step 2 we extract information comprises of commits, issues, pull request, and source code structure. So further in step 3 we take care of situation where a developer uses multiple account or email IDs and deduplicate such IDs. In step 4, 5, and 6, we store conceptual and structural links among the commits, issues, artifacts, and subsystem. So to move further, in step 7, we build software interaction network from developers' involvement in issues, such as contributing code or commenting. We model the developer interaction network as an undirected graph with developers as nodes and edges between those developers that interact. For the purpose of community detection, we used OSLUM, which finds communities present in developer interaction network. And in step 9, which is about software development team extraction, in contrast to the interaction network community structure, a developer becomes member of a software development team purely based on one's contribution to source code or involvement in issues, regardless of interaction with other developers. So in step 10, we calculate the overlap or to extent to which these communities matched or overlap the subsystem developer teams. And in step 11, we see how communities change over time It means how developers join and leave subcommunities. Here we discuss about the results. We slice the project lifetime into time windows of 4 months. So here we have the count, size, and average conductance, which is a community quality metric of communities found for each time window of one of our studied projects. So if you observe here, the number of communities ranges between 1 and 8. So our results show that the observed developer interaction network exhibit a clear community structure. So in order to see how well a software development team matches a developer community, this figure shows the overlap results of each of our project. As we can see, all these projects are diverse with respect to how well software development teams typically overlap a single community. We also studied how stable are the detected communities across time compared to software development teams. Here we need to measure internal stability of the communities between two subsequent intervals to understand how much the developer interaction network structure itself changes. We then compared the internal stability with the software development team stability, and we find out that the internal stability is not that strong, hence implying the communities change considerably across time. However, on the other hand, we find that the SDD or software development team stability is stronger. This indicates that developers remain in the same software development team but switch among communities. Based on our results, we draw the conclusion that there is no correlation between communities and software development teams. It also means that working on a subsystem does not cause interaction links to occur largely among software development team members. As a future work, we are interested in studying what other factors might bring about the lack of correlation between the communities and software development teams. With these words, I thank you. Our results are presented in more detail on this supporting online material link, and here is also my email ID. Thank you very much again.
Question and answer session. I'm with Usman here. He's ready to take questions from the audience. I don't see one right now, so I will start with one. So regarding the third research questions on membership evaluation, I saw in the paper that you evaluated sliding time windows and you compared at the instant t if any pair of developers that were in the same subcommunity at one instant were again in the same community at the next instant. My question is, why do you have to consider pairs of developers instead of individual developers who are in
we wanted to see, we have like for one particular community, we pair up like with each individual with other individual, like we have a multiple pairs, and then we see if they have the same pairing in the next window. So basically this gives us like an idea, like is there any fluctuation in the community? I mean, if they have changed heavily or not, for example.
Yeah, but you can have also, if you look at individual developers, if you why do you have to think about pairs? That was my questions.
Yeah, well, at the end the result is like, yeah, who is here attached to or interacting with other developer is also interacting with the other. So it's based on interaction.
It's to capture the interaction, the pair. Okay, thanks. So we have two questions. First from John Knoll. I'm intrigued by your last comment. In your example, Eve seemed to be a link among all the three subsystems. Wouldn't she therefore be a link among them?
So Eve seemed to be a link among all three. Should there be a link among them?
Is it clear?
I might need to see the figure myself, because
okay,
so I will answer this question.
Maybe we can move this to the breakout room. Apologies, John. You may want to speculate more in the chat meanwhile, so it's clear for the author. But thanks for the questions. Next one from Maria. Can you give some example of the type of communities you studied? about the community topics?
Well, these are the open source product communities, and the way we define a community is they are set of developers that share responsibility or interest, for example, and they could be like working on the same subsystem. So that's how we form the communities, and that's how we see them as a community. But they are the sub part of interaction networks, which are based on while they, for example, they comment on an issue or they commit something which is linked to that issue. So basically, how they interact in the open source system. That's how we study them.
Okay, thanks. Actually, John question reminds me of something that I noted while reading the paper. Is the fact that when you, the main finding of your paper is basically that you find limited overlapping between subsystems and some communities, and you speculate that this is because, developers need to be members of many sub-communities to interact and coordinate. So I wonder if John was noticing that, in the example, you have Eve as a member of multiple sub-communities. So if it can help you if you look at or try to find gatekeepers in these communities. I mean, there is plenty of evidence from previous work on OSS and even in industrial setting that in developer sub-communities, there are people who serve as gatekeepers and connect cliques together of developers. So I wonder if you look at this, it may help you, understand or speculate
Yeah,
more.
we are well aware of this concept that there are gatekeepers who are like connected to more than one community, or they are like they are the person who bridges between one community and another, and we are aware of that. But in this study, the idea is like not just to see the overlap, but also to see which subsystems are like less communicated compared to others, for example. And maybe practitioners or researchers will find that interesting to point out that area. And for the practitioner point of view, I mean, you can have a more communication there so that there is less overhead in that sense.
Okay. Thanks. Well, let's thank Usman, and we will be able to take further questions in the breakout room. Let's move on to presenting the other paper, implementation of technology acceptance model in partially distributed teams, presented by Shinobu Saito from MTT Japan. I'll see you in a few minutes.